let's review a little bit of regression stuff. And I'm going to work through the first 6 problems on here just to give you a push in the right direction. So here we go. I just bumped my camera. There we go. The data in this table represent, by the way, data is plural. So it looks like it's bad grammar, but it's not. So it's plural. The data in this table represent the U.S. health expenditures on medicines by year since 1990. So years since 1990, that actually would be 1995, obviously, because it's 5 years since 1990, 1996, 97, and 98. And this is how many billions of dollars we have spent on health care. So before we even touch the calculator, let's just look at number 1. What's the trend? Do expenditures increase or decrease over time? How will this affect the slope of the line? A lot of the problems that are on this deal with slope. And I want us to kind of process that and understand it. So what is the trend? Is this increasing or decreasing? You know the answer to this. This is not too difficult. Here we go. But how will it affect the slope? Okay, if something is increasing, and this is going to be common sense when I ask it, but if something is increasing, does it have a positive or a negative slope? It's going to have a positive slope. Positive slope. Okay, number 2. This is the one that's going to take a little bit of time. So here goes. We're going to press, and you have this on your yellow sheet, but we're going to press Stat and Edit. You might have some stuff in there. If you do, you can clear it out. If you go up and press Clear and Enter, do not hit Delete. It complicates things. Let's clear this one out as well, and we'll type these things in. 5, 6, 7, 8. 8.9, 9.4. Pause the video if you need to, or if you want to skip through this because you've already got this stuff. You're good. All right, we're going to go to the scatter plot. So second and stat plot. And we need to turn plot 1 on. So press Enter on on. It may already be on. Now we also need to look at this and see what the general shape is and see if it truly is increasing, which we know it is. But if it was harder to tell, we would need to look at it. So we're going to press Zoom. And it's option number 9. So because I know it's 9, I'm just going to press a 9. There we go. Now, I have a random line through mine. If you have a random line or whatever through yours, you can clear it out. If you press y equals, you'll see you have an equation there. You might have an equation. If you press clear, it will be gone. Press graph again, and there you go. Okay, obviously it's increasing. So plot these data in your calculator and find the equation for the line that best fits these data. So we need to find out what the equation is, and now we're to the point where we're going to press Stat, go over to Calc, and choose Linear Regression. Now, just for fun, let's press vars, yvars, enter on function, and we're going to pick y1. Now, whenever we hit enter, it's going to save that equation in y1. So there we go. Let's also write it down. So number 2, we have plotted it. Y equals 0.57x plus 6.02. Okay, number 3. What is the slope? Well, that's easy. The slope in this situation, assuming that this is M and this is B, and you know that, and that is a very safe assumption because it's true. What is the slope? Well, I'll tell you exactly what it is. The slope is 0.57, but now here's the tricky part. This is where people always get stumped. What does it represent? Slope always represents, and this is going to be a little wordy, I'll write it down. It's going to be y divided by x, but I like the word per instead. Y per x. Slope is a rate of change, and it is one variable in comparison to another. So let's put this in good plain English. What does it represent? It represents the billions of dollars that were spent per year. It represents the rate of change of billions of dollars per year. So the real final answer is going to be billions of dollars spent per year. We'll just throw this in on medicine. You might be thinking, I have no idea what you're talking about, Mr. Reader. Well, let me tell you again. There's y, there's x, and there's an extra phrase. Y per x. That's exactly what it is. What is the y-intercept? Well, it is 6.02. What does it represent? Well, I'll tell you exactly what it represents. The y-intercept always is, this is going to sound dumb, but the y-intercept is where you cross the y-axis. Duh. You cross the y-axis where x equals 0. So what does it represent? And the big answer for this, for any of them, is going to be the value when x equals 0. So for this problem, we're not going to put the value when x equals 0. That's just the generic answer. Same thing here. This is just the generic answer. But what does it really represent? It represents the amount of money that was spent in year 0. Well, year 0 would have been actually 1990 itself. So what does it represent? 6.02, let's put a dollar sign, billion was spent, according to this trend, on medicine in the U.S. in year 0. And it's obviously not year 0. There was no year 0, actually. But according to this, since we're counting from 1990, that is 0. So in 1990. Okay, number 5 and 6 won't take very long at all. Using your equation, how much money was spent on medicine in 1999? Okay, let's figure out what they're asking. They're asking how much was spent on medicine. So are they asking for X or asking for Y? Well, they're asking for how much was spent, expenditures. They're asking for Y, and they gave us X. They gave us 1999, so let's be realistic. We're not going to plug in 1999. That was 9 years after 1990. So in this situation, X equals 9, and we got it from that. So we're going to use our equation. So Y equals 0.57 times 9 plus 6.02. And we'll just type that in the calculator. 0.57 times 9 plus 6.02. And we have 11.15 billion. That's a lot of money. Okay, number 6. In what year, pause right there. In what year? It's asking for year. So is it asking for X or Y? They're asking for X. In what year? Okay, so they better give us Y. Would you expect there to be, so they gave us 15 billion. So that'd be nice. 15 billion is Y. There we go. We got it from that right there. Y equals 15. So we're going to plug it in. 15 equals 0.57x plus 6.02. This is where all that solving we've done is going to come in real handy. We're going to solve that. We're going to subtract 6.02. I'm running out of room here. I'm sorry. 6.02 is going to get a little sloppy. 15 minus 6.02. 8.98 equals 0.57x. We will now divide that by 0.57, and x equals 15.75. Now, in what year can we expect that to happen? You know, we can get tricky and have a big argument about where to round and all that stuff, but it's really in year 15. So 15 years, that looks like another decimal, but 15 years after 1990 would be 2005. There we go.